Recently, I've been doing a lot of travel, and rather than using my Linux laptops, I've been using my MacBook Pro. Whilst the battery life and performance are really fantastic, there are a couple of quirks that I've had to get used to, especially when coming from Linux. One of these is the lack of a default package manager. Fortunately, there are a few third-party options when it comes to macOS, with the most popular one being Homebrew. However, in my case, I actually prefer to use something else, one that I think is a lot more powerful. Let me show you why. Here I have a fresh copy of macOS on a brand new machine. By running only 3 commands, one to download the package manager, the second to download my configuration, and the third to install it. Once this third and final command finishes, this fresh macOS system will now have all of my apps, packages, and system settings applied. This includes all of my favorite GUI applications, such as Firefox, Obsidian, and even Yoink, which comes from the Mac App Store. Additionally, not only is my favorite terminal emulator Alacrity installed, but it also has my configuration applied as well, including my favorite color scheme, Tokyo Night. Not only this, but if you take a look at my shell, you'll notice that Z Shell is running my Zenful configuration, with all of my custom settings applied. This is because, in addition to installing all of my favorite GUI apps, the package manager has installed all of my favorite CLI applications as well, including Tmux, Zoxide, and even NeoVim, all of which have their respective .file configurations set up as well. In addition to installing packages and their configurations, the package manager has also configured my Mac system settings, such as setting up a faster key repeat behavior, ensuring that new Finder windows default to the column view, and even configuring my dock settings, such as enabling auto-hide and defining the persistent apps that will appear on it. All of this is achieved by using the Nix package manager with Nix-darwin, and after having used it for a couple of months now, I can safely say it's forever changed the way I work on macOS, for the better. Nix allows you to specify every application, package, system setting, and configuration on your machine in a declarative manner. This includes CLI tools, applications from the Mac App Store, and even apps from Homebrew itself. This is done using a functional language called Nix, which allows for a high level of expressibility in your Nix configuration. It's very similar to, say, using Lua when it comes to configuring NeoVim. Because of this declarative nature, it allows you to easily reproduce your configuration across multiple machines, and even across multiple operating systems. Which means, in my case, I'm able to keep my MacBook Pro and Linux laptops in sync with their installed packages and configurations, making sure that my environment is consistent across each machine. Additionally, because my entire system configuration is stored in Git, I get all of the benefits that comes with using version control as well. This means if I accidentally make a change to my configuration that causes something to go wrong, I can easily just roll it back. Not only that, but we can also use the Nix package manager itself to roll back to a previous version of our system configuration, returning our system into a working state. So yeah, Nix provides a lot more functionality than just using Homebrew by itself. But there is a catch. Nix has somewhat of a steep learning curve, and the declarative nature of managing packages and configuration can be a challenging mindset to migrate to. So in this video, we're going to take a look at the foundations of getting Nix working on macOS with the Nix-darwin module. Then we'll take a look at how to install packages from the Nix repository, as well as how to install applications from both the Mac App Store and Homebrew as well. Lastly, we'll round off this video by showing how to use Nix to configure our Mac system settings. As for all the other features that Nix provides, such as managing .files, I'll be saving those for another video. To set up Nix and Nix-darwin is actually rather simple, and only takes a couple of steps. However, as I've already set it up on my MacBook Pro, I'm gonna need another machine. Fortunately, I have a fresh M1 Mac Mini to use for this video, which is running the latest version of macOS at the time of recording, Sonoma 14.6.1. However, I made sure to hold off on releasing this video until I could confirm that everything was working with the newest version of macOS, Sequoia, which I can confirm that it does. Hooray! In order to set up both Nix and Nix-darwin, we first need to install the Nix package manager. This is done using a single command, which we can find on the downloads page of the NixOS website, under macOS. Now all I need to do is copy and paste this command into the terminal, which will then prompt me to answer a couple of questions before installing Nix on my system. One thing to be aware of is that the Nix installer is rather involved, as it creates a separate Apple volume and a number of user accounts. For me, this isn't really too much of an issue, but definitely speaks to the complexity that I mentioned earlier, and something to be aware of. In any case, once the installer is finished, we can then check that it's working by running the following command, which will download and run NeoFetch, showing me that everything is working as expected. Before we move on, I just want to take a minute to appreciate how awesome the Nix shell command is. As you just saw, we used the Nix shell command to download and run NeoFetch. Pretty simple. However, what's interesting about this is that we did it without actually installing NeoFetch onto our system. In fact, I can prove this by trying to run NeoFetch again, which shows that the command isn't found. This is because the Nix shell command will download packages and load them into a temporary environment, rather than installing them system-wide. This makes it useful for running one-off commands, rather than installing the packages onto my system, causing it to bloat. Now that we have the Nix package manager installed, let's go about adding in the Nix-darwin module. To do so, I'm going to create a new directory in order to store my configuration. You can pretty much set this to wherever you want. In my case, I'm going to set this to be a new directory called Nix inside of the user's home folder. If you choose to follow along with the instructions in the Nix-darwin documentation, then this will tell you to create it in the .config/nix directory. You can choose whichever location you prefer. The next step is to define the first file for our Nix configuration. When it comes to Nix-darwin, there's two approaches we can take, either by using Nix channels or by using Nix flakes. My personal preference is to use the flakes approach, as it provides better composability through the use of Git, and improved reproducibility through the use of a lock file. It also enables Nix to act in a more decentralized manner, and makes installing packages from third-party sources, such as GitHub repositories, a lot easier. In order to use Nix-darwin with Nix flakes, we can use the following command copied from the Nix-darwin documentation, pasting it into our terminal. However, in order to run it, we need to pass in the extra experimental features flag, with the values of Nix command and flakes. Now, when I go and execute this command, it will create a new file in the directory called flake.nix. Let's go ahead and open this up in our favorite text editor. In my case, however, my favorite text editor isn't installed, so I'm going to use my second favorite text editor, Vim, which comes on macOS by default. Opening up the flake.nix, let's take a couple of minutes to go through this line by line. Just a heads up, this part is somewhat comprehensive. So if you want to skip to the part where we start installing packages, just head to the timestamp on screen. Back in our file, the first line contains the flakes description, which is currently set to the string value of example Darwin system flake. Let's go ahead and change this to be something a little more personal. In my case, I'm going to set this to Zenful Darwin system flake. Much better. Underneath this description, we have a block called inputs. Every Nix flake is made up of both an input and an output section. The input section is used to specify the dependencies of the flake. In our case, our dependencies are the Nix packages repository and the Nix-darwin repository, both of which are set to their respective GitHub URLs. In the case of the Nix packages dependency, we're setting this to point to the unstable branch, which contains the most recent versions of packages defined in the Nix packages repository. If you want, you can set this to point to the stable versions instead, by changing the branch name to the most recent release. However, personally, I would recommend keeping it pointing to unstable. As well as defining the URL of our dependencies, we're also adding in a configuration to the input of the Nix-darwin dependency on the following line. This line tells the Nix-darwin dependency to set its own internal dependency of Nix packages to follow the dependency we've specified in this flake. By doing so, it keeps both of the Nix packages of this flake and the Nix-darwin flake in sync. Underneath this inputs block, we then have the start of our outputs expression, which takes the inputs as a parameter. The first line of our outputs is defined by the let keyword, or expression. This expression is used to define any local variables for inner expressions, i.e. our output's definition. In this case, we're defining a local variable called configuration, which is a function that accepts a parameter containing a value of pkgs. Inside of this function is where our main configuration lives, defining a number of properties such as our system packages, enabling the Nix daemon, adding in the experimental feature flags of Nix command and flakes, and ensuring that the Nix commands are available for C shell, amongst other things. This configuration function is where most of the changes in this video are going to take place, so we should be more familiar with it by the end. Initially, however, each setting inside of this configuration has an associated comment, letting us know what each option is doing. If we scroll down further, we should come across the in keyword, which marks the end of the let expression. Below this is where we can find the output's inner expression, which defines our flake's output. A single flake can provide multiple different outputs, either of the same or different types. In our case, we have two different outputs. The first is a Darwin configuration named simple, which is created using the Darwin system function of the Nix-darwin module. As I mentioned before, a flake can provide multiple outputs. So our flake could provide multiple different Darwin configurations, each defined with their own unique name. In this case, however, we're only defining a single one named simple. Passed into this Darwin system function is an option named modules, which is a list that makes up the entire system configuration. In our case, this list contains a single element, which is the familiar local variable of configuration that we looked at before, defined in the above let expression. We'll add another module to this list later on in the video to show you how that works. The final line of this flake is another output value, which is exposing the package set from the Darwin configuration named simple. That covers the basic overview of the flake.nix. Now let's look at getting this installed onto our system. In order to get our initial install of Nix-darwin working, we first need to make a couple of changes. The first of which is to change the Darwin configuration name of simple to something else. In our case, we want to change this name to be a little more descriptive. A common approach is to use your machine's hostname, which you can easily achieve by running the following command found on the Nix-darwin documentation. In my case, however, I find that my hostname can sometimes change if there's a conflict on my local network. So instead, I prefer to explicitly define this to something else that I can remember. In my case, I'm going to define this as Mini, as this is the configuration used for my Mac Mini. With the configuration name defined, the next thing to do is to change the system architecture, which is defined on the following line. As I'm using an M1 Mac Mini which uses Apple Silicon, I need to change this from x86 to AArch64. With that, the configuration is now ready to be built and applied. In order to do so, let's first copy the following command from the Nix-darwin documentation, then paste it into a new terminal window. Before we can execute this command, however, we need to make a couple of changes to it. The first is to change the directory where the flake lives, which in my case is the Nix directory found in the user's home folder. Next, I need to add the name of the configuration I want to use that's found in the flake. If this isn't specified, Nix will choose the machine's hostname by default, which is why it's a good idea to use the hostname in the configuration. In my case, however, I explicitly defined my configuration name as Mini, so I need to set it in this command using the following syntax. Lastly, we need to add in the extra experimental features flag as we did before, setting this to Nix command and flakes. Now we can go ahead and execute this command, and after a short while, Nix-darwin should be installed. We can verify this by running the following which command, which shows us that the Darwin tools have been installed on our system. With that, we're now ready to start managing some packages. First things first, let me show you how to install packages from the Nix repository by installing my favorite text editor, NeoVim. When it comes to installing packages on Nix, things work a little differently compared to other package managers. For example, when installing a package using Homebrew, you would use the brew install command on the CLI, passing in the package name. Nix does provide the ability to do something similar by using the nix-env command. However, personally, I would recommend against using this if you want to use Nix, as by doing so, it goes against the main reason to use Nix in the first place, its declarative nature. So if we don't use the nix-env command to install packages, then how do we go about doing it? Well, to do so is actually rather simple. First things first, head on back over to the flake.nix and navigate to the following line which contains the environment.system packages list. This value specifies the list of packages that you want installed on your system for every user. This means that in order to install a new package, we need to add it to this array. You'll notice we already have an entry for Vim defined in this list. And because we've installed the Nix configuration already, this means we have the Nix version of Vim installed on our system. Let's go ahead and replace the Vim entry with one for NeoVim. Now, to redeploy this configuration, we can use the Darwin rebuild switch command, which is available to us as part of Darwin Nix. Here, I'm specifying to use the flake, which is inside of my Nix directory, and making sure to also define the mini-config inside. Once it's complete, I should now have NeoVim installed and available on my system. Not only that, but the Nix version of Vim that was installed is no longer. This is due to the declarative nature of Nix. Anything that is specified in this configuration will be, and anything that isn't will not. This is great for reducing the amount of bloat installed on your system, usually from installing a package, using it once, and forgetting to remove it. Now that we know how to install packages, let's take a look at how we can actually discover them. This is done by using the Nix search command, which acts very similar to other package managers. The key difference here, however, is that the first argument of this command is the package repository you wish to search through, as defined in your Nix config. In my case, I want to search the Nix packages repository, so I pass that in as the first argument, followed by the name of the package I want to install. In this case, tmux, which will show me the list of packages matching that name. If you prefer to not use the command line to search for packages, you can also use the website of search.nixos.org. Whichever approach you take, once you have the name of the package you wish to install, all you need to do is add it into the environment.systempackages list and run the same Darwin rebuild command again to install it. In addition to installing CLI packages, Nix can also be used to install GUI applications as well. When it comes to installing these, there are a couple of different approaches that we can take. The first of which is to install these from the official Nix repository. For me, this is the preferred approach, as it works cross-platform, meaning any packages I install from this repository should be available on my Linux machine as well. Let's use this approach to install my favorite terminal emulator, Alacrity. In order to do so, all we need to do is add the Alacrity package into our environment.systempackages list. Then rebuild our configuration using the Darwin rebuild switch command. Now, if I go and check my applications in Finder, I can see that Alacrity has been installed under the Nix apps folder, which I'm able to open up and use. Unfortunately, however, there's a bit of an issue. If I try to search for Alacrity using Spotlight, the application doesn't appear. This is because NixOS uses symlinks in order to link the applications from where they're installed into the application folder. Unfortunately, however, macOS doesn't actually index symlinks for Spotlight, although interestingly, it does manage to index these for Launchpad. In any case, if we want these applications to appear in our Spotlight results, rather than generating symlinks for these applications, we need to configure Nix to generate macOS aliases instead. Fortunately, this isn't too difficult to achieve. Before we do so, however, let's take a minute to quickly resolve the warning at the bottom of the Alacrity window, letting us know that the JetBrains MonoNerd font isn't installed. Fortunately, we can declaratively install fonts using Nix. To add a font to the Nix configuration is as simple as adding the desired fonts to the packages.fonts list. However, unfortunately, there is no JetBrains MonoNerd font available in the Nix package repository. Luckily for me, that doesn't matter, as I can generate my own version of the JetBrains MonoNerd font using Nix. In order to do so, all I need to do is add in the following line, which calls the override function of the Nerd Fonts package, specifying the JetBrains Mono font. Now when I rebuild this config and restart Alacrity, the warning message goes away. And if I check my font book, I can see that the JetBrains MonoNerd font has been installed. Great. With our font installed, let's go back to fixing Spotlight for our Alacrity application. First, I need to add the config value into my configuration inputs. Then I need to add the makealias package to my system packages. Next, I then add in the following activation script, which will create aliases which are indexed by macOS instead of symlinks for all of the applications I install. As this is a lot of code, I've created a code snippet you can use to copy and paste this into your own configuration. You can find a link to it in the description down below. Now when I go to rebuild my configuration, you can see that Alacrity is copied over, and when I open up Spotlight and search for Alacrity, it now appears. One thing to be aware of when using Nix to install applications is that non-free applications, i.e. non-open source, need to have a special configuration value defined. For example, if I try to add the Obsidian package, which isn't open source, unfortunately, you'll see that I get an error mentioning that I'm trying to install a package with an Unfree license. The simplest way to resolve this is to add the following line into the Nix configuration, which configures Nix to allow installing Unfree applications. Now when I rebuild my Nix configuration, you can see that Obsidian is now installed, which I can verify by opening up Spotlight and searching for it. When it comes to installing GUI applications, I try to use the Nix repository as much as I can, as these will be available on both Linux and macOS. Unfortunately, however, not every Mac app is available on it, so for any missing applications, we have to use another approach. That approach is by integrating Nix with Homebrew, which allows us to install Mac applications either through Homebrew casks or via the Mac App Store. To add Homebrew to our system, we have a couple of options. We can either install it manually through the conventional method, or add in another module to our Nix configuration to install it declaratively. Personally, I prefer to use the declarative approach, as I like to use Nix for configuration as much as I can. We can install Homebrew declaratively by using the Nix Homebrew module, which has some decent documentation on how to get started, showing you how to set up a new Homebrew installation or migrate an existing one. Because I don't have Homebrew set up on this machine, then I'm going to follow the new installation instructions, which means adding the Nix Homebrew module to my Flake inputs, and then adding an entry into my Darwin configuration modules. Inside of this entry, I make sure to enable the Nix Homebrew module, followed by also enabling Rosetta, given that I'm running Apple Silicon. Then all that remains is to specify the user owning the Homebrew prefix, which in my case is my username. If, like most people, I already had Homebrew installed on my machine, then I would need to add in the following line of automigrate equals true. Now, if I go ahead and run the Darwin rebuild command, it should install Homebrew onto my system, which I can verify by testing the brew command. With Homebrew installed, I can now configure it using Nix-darwin. To do so, I need to add in the following Homebrew entry into the configuration, setting the enable option to be true. Then we can define which casks we want to have installed. In my case, I'm installing Hammerspoon, Firefox, Ina, and the Unarchiver. Now, when I run the Darwin rebuild command again, Nix through Homebrew will download and install the specified casks onto my machine. When it comes to managing Homebrew packages using Nix, I like to ensure that this is done as declaratively as possible. Therefore, I like to set the following onActivation.cleanup option to Zap. By doing so, this will ensure that only packages specified in this configuration are installed, and any Homebrew packages that have been installed outside of the Nix config will be removed. As well as casks, Nix can also be used to manage other installation types from Homebrew. These include standard brew packages using the Brews option, system services using the Services option, and Mac App Store applications using the MAS Apps option. Let's take a look at how to install a Mac App Store application by installing one of my favorite ones, Yoink, which is an absolutely fantastic utility tool when working on a single screen. In order to install Yoink, we need to add a key value entry into the Mass Apps option inside of our configuration. The key for this can be any string that you desire. In my case, I'm going to define this as Yoink. As for the value, this needs to be the app ID as found in the Mac App Store. You can obtain this ID one of two ways. The first approach is by opening up the Mac App Store and navigating to the page of the app you want to install. Then you can copy the share page link to your clipboard and paste this link into your text editor, pulling out the ID. The second approach, which is my preferred way, is to use the Mass CLI tool, which you can install through Homebrew. To do so, let's add in the Mass package into the brews list inside of our configuration, and go ahead and rebuild it using the Darwin rebuild command. Once it's installed, we can then use the Mass search command, passing in the name of the app that we're looking for, which in my case is Yoink. After a short while, we should then receive a list of apps that match the search term with their Mac App Store ID. Whichever approach you take, once you have the ID in hand, you can add it as the value in the Mass Apps entry, followed by then rebuilding your config, after which the app should then be installed. In order for installing Mac App Store apps to work, you need to make sure you're logged into the App Store and that you've purchased the app already. Now that we know how to both add and remove packages and applications, let me show you how you can update them. Before we do so, however, let's take a moment to commit our current configuration to a Git repository. Here, there are a couple of ways to do so. You can either commit this configuration in its own brand new repo, or do what I do and add it to an existing .files repository. Whichever option you choose, make sure that you're committing your changes frequently and often, as it's much easier to debug smaller increments if you ever need to. You'll also want to make sure to push these changes to a remote repository, such as GitHub, so that you don't lose them. With our configuration committed, let's go about upgrading our packages. This is done by running two commands. The first is to update the Nix Flake, which will cause any inputs defined in our Flake, such as the Nix packages repo, to be updated. Once the Nix Flake update command has completed, if we run a git status, you can see that this has caused some changes in the Nix Flake log file. Now we can run the Darwin rebuild switch command again, and it should perform any available updates for our installed packages before building and applying our configuration. When it comes to upgrading Homebrew packages, there are a couple of options we can take. With our current configuration, this is actually done manually by using the brew update and brew upgrade commands. Personally, however, I like to instead do this whenever I upgrade my system using Darwin Rebuild. So in order to make that happen, I need to set the following two options to true in the configuration, which will enable both auto updating and auto upgrade. With that, we've covered the basic usage of managing packages with Nix-darwin. Now let's take a look at how we can actually use Nix-darwin to configure our system settings. As I mentioned before, we're able to use our Nix configuration in order to set up a number of macOS settings declaratively. For example, one thing that I like to enable on macOS is to automatically hide the dock. Whilst we're able to enable this using the Settings app, let's take a look at how we can enable it using Nix-darwin. As I already have this enabled, I'm first going to disable it using the Settings app. Now we're ready to enable it using Nix. To configure system settings in Nix-darwin, first add in the following block for the system.defaults option, which is where most of the macOS settings in Nix are defined. Then, in order to enable auto-hide on the dock, I can set the following option of dock.autohide to be true. Now, when I rebuild the configuration, we can see that the dock is now hidden and will reveal when I move my mouse down. As well as auto-hiding the dock, there are many other settings you can define. To discover these, you can use the Nix-darwin documentation, either through the command line using man pages, or with the following darwin help command, which will open up a web browser with HTML documentation. One of my favorite places to check for documentation, however, is mynixos.com, which provides a nice hierarchical view of all of the options available for a given module, in this case, Nix-darwin. When it comes to my own system settings, I typically have the following options configured. The first of these defines the apps that I want to appear on my dock at all times, which in my case is Alacrity, Firefox, Obsidian, the Mail app, and the Calendar app as well. You'll notice for the apps that I installed with Nix, I'm referencing their PKG path instead of where they were aliased to. The next setting is used to ensure that any new Finder windows I open up default to the column view, which is honestly one of my favorite things to configure on macOS. The next setting is used to disable the guest account on the login page, followed by setting the clock to use 24-hour time. The last two settings set the color theme to be dark mode, and set the key repeat time to the fastest value there is. That wraps up the basics of using Nix and Nix-darwin for package management and configuring macOS settings. Next time, we'll take a look at how to add dot files into our Nix configuration, and how to manage them declaratively using the fantastic Home Manager module. If you can't wait that long, however, then I recommend checking out Vimjoya's YouTube channel, who has a lot of great content on setting up Nix and NixOS, which can easily translate into Nix-darwin. Otherwise, a big thank you for watching, and I'll see you on the next one.